We are, well, it's actually time. We are 10 after. So, welcome everybody. We are very excited for you all to be joining us today. My name is Jackie, and I'm coming live from the California Academy of Sciences in San Francisco, California. Now, before we start, I have a couple of things to let you know, some housekeeping before we start. We are a very large group. We have over 50 classes joining us today. So you can use that chat box to let us know and share your ideas and observations. You can also change your settings to all panelists and attendees to let everybody know what you're thinking. Otherwise, just ourselves and an educator on the side will be able to see everything that's coming into the chat box and those questions that you might have. There'll also be times where we might ask you to turn and talk to a partner sitting next to you. And if you don't have a partner, you can actually write down some of your ideas on a paper or even on in the chat box itself. So this is a couple of ways that we are going to be interacting today. But I want to say welcome everybody, and we are actually looking at the outside of our museum right now, the California Academy of Sciences. Now it looks beautiful on the outside. We see that green living roof. We're inside Golden Gate Park, but I think what's very special is actually inside our museum. And if we take a look inside, there is an aquarium where we get to explore the different types of things that live in oceans and waters or near the water. We have a whole actual coral reef we can explore. There's a rainforest with live animals and plants, and we get to explore that different type of habitat. But today we are going to be focusing on our planetarium and looking at the stars in our night sky and see what we can find. So to do this, I'm actually going to invite a friend of mine, Josh, who is a planetarium presenter here at the California Academy of Sciences. Welcome, Josh.
Hi, everybody.
So how long have you been working here at the Academy?
I'm just past my 9th anniversary.
Congratulations.
Thank you.
Well, what got you into astronomy or into working at the planetarium?
Where I grew up, we didn't have great skies, but I had a friend who had some telescopes. We got invited out to a star party where a couple local astronomers brought their big telescopes. And I was able to play with one and find Jupiter all by myself. It was a pretty big moment in my life. I got very excited. Since then, I went on to high school, and in high school, I had a teacher who really helped us tackle astronomy and understand it and feel like we could do it, really do science. And that got me really excited about it. So going into college, I decided I was going to be a history major. My friend Jackie talked me into becoming an astronomy major, and I completed my degree. And from there, came to work at the academy. I'm continuing my education, but astronomy is a special science because it's a science that touches on everything else, and it's something you can do for your whole life, and there's still new stuff to learn.
All right. Well, I'm excited that we get to explore the night sky with you, and we're using our planetarium software today to kind of look at what's out there. But is there a way that other people can explore the night sky on their own?
So if you folks are in this place where you have a nice dark sky, all you need is your own 2 eyeballs. If you have something like binoculars or a telescope, even a camera with a zoom, there's a lot more cool stuff you can see. But even if you just have a computer, there's cool programs like OpenSpace from openspaceproject.com or the Worldwide Telescope that allow you to use your computer to see all sorts of amazing stuff.
And if you didn't catch that, that's okay. We will be sending it in an email. But let's go ahead and tour our night sky, shall we?
Sounds great. So we're showing you the sky that we see from here close to our museum in San Francisco. Right now, looking around, I can show you our academy over here. You've got one of our domes right at the bottom. That's where our planetarium lives. Over here is where our rainforest lives. That's the elevator that takes you up to our living room. So in this sky, we can see our sun is up, and that gives us that nice bluish color. Our sun rose in which direction? Anybody remember where the sun rises? If you think you remember, tell the person next to you. Okay, so you can maybe see it down at the bottom there. I'm going to change our view ever so slightly. So this is our eastern direction. Now looking into the east, we can see where the sun might have risen, but our sun actually is very far to the south, where we started our view, because we're very close to winter. Now, in winter, we get to see our sun rising very low in the sky, as opposed to very high. When our sun is low, we tend to have chilly days in winter. When our sun is very high up, we have very warm days. So we say higher, hotter, lower, cooler. So when the sun is high in our summer months, we get nice, long, hot days. When the sun is low, we get those short, chilly winter days and long, freezing winter nights, depending on where you live. That could be hotter or colder. Okay, so looking at our sun rising there in the sky, you can see it getting higher and higher. As we get towards noon, we will eventually see our sun get to its very highest point, and then it will begin to set. Now, we could wait around for a couple hours. This software is tracking second by second exactly what's happening, but I think we got other stuff to do today. So instead, we're going to use the magic of the planetarium and give us a little bit of a fast forward. So when our sun rises, we can see it getting higher and higher. We are eventually going to get a chance to see our sun set. And when it does, our stars pop out. Now, I want to make sure that we have a chance to see the stars we are seeing tonight. So we are going to go forward to, pardon me, right when our sun goes down. Here we go. And the second our sun touches the horizon, you'll notice things get a little darker and some stars pop out. Now, this isn't going to be the best view of our star. When the sun is just at the horizon, you still get a little bit of light coming up. And because of that, we can see a few of our brightest stars pop out. But if you go to someplace with a really dark sky, far away from city lights, you get to see a whole bunch more. In our planetarium, again, we can pretend to be able to do that. All we got to do is wait a couple minutes for our sun to get a bit lower in the horizon. And we're going to pretend we're in a spot with no buildings. That's a really big deal because buildings block your view. So we are going to fade down those buildings and give us a view of a pristine dark sky. Here we go. Now, one really cool thing I want to point out to you is happening in the western sky. In the western sky, right when the sun goes down, we should have a chance to see a very bright object. Now, when you go outside, it's going to be hard to miss this thing. It is so bright, you'd have to really work to avoid it. It is something called the planet Venus. Now, we should be able to see Venus's marker right there in the corner of our view. And that very bright object is our next door neighbor planet and one of the brightest objects in the sky when it's visible. Now, this isn't a part of the sky we call the western sky because it's in the setting part of the sky. There's actually a couple other bright stars hanging out here, 1, 2, 3 on our screen, what we call the summer triangle. Now, we're very close to the winter season. It's just about to start. And when winter is officially started, you're going to notice the summer triangle is setting very soon after the sun goes down. It's not going to be a very good object to see. Venus, unfortunately, is in this same part of the sky, so it's the kind of thing you got to prioritize. Look for it when the sun goes down. Don't try and find it at midnight, because it'll already have vanished. Now, what would you see if you were to point a telescope at Venus? Something really cool. Now, look at this thing. Something's kind of weird with that planet. Whisper to the people next to you or share your answer. What's going on? Why does it look so funny? What's funny looking about it? You can see some dark stuff on there. It looks kind of like an oval or an egg, right? Like somebody stepped on Venus. That's not the case. It's still round. What we're seeing is where sunlight is bouncing off of Venus for us to see from here on Earth. Because Venus is a round object, and because we're both going around the same light source, our sun, we don't usually see Venus completely lit up. We usually see it, what we would think of as like a partial phase. Here's a question. Have you ever seen the moon with about the same shape as Venus? We would call that maybe a gibbous moon. So this would be a gibbous Venus. Now, as Venus continues around the sun, eventually we're going to get a half Venus and then a crescent Venus, really a quarter Venus, then a crescent Venus. So we're seeing a 3D object moving in really four-dimensional space. And as it's moving, we get a chance to see it change how much light is striking it. So looking at Venus, this is a really cool planet. It's fun to think that this is just about the same size as Earth. So if you were on Venus looking towards Earth, we would just appear as a kind of brightish bluish dot instead of a kind of brightish yellowish dot. Now, looking at all these awesome stars, we are seeing the stuff that is the kind of toughest to see part of the sky. It's not going to stay around very long. It's going to disappear pretty quickly after the sun goes down. If you want to find some stuff that's going to be there all night long that gives you some prime viewing opportunities, we have to look towards the winter skies. Now, for our winter skies, we are going to be looking for a few constellations, and they are ones you might recognize. We are going to imagine tilting our head back towards the east to see if you recognize anybody. So here are two very famous constellations. The first one I want to talk about is this guy. That is Orion. Now, Orion the hunter is supposed to be a giant, prestigious hunter. Kind of hard to imagine from the stick figure, but I'll see if we can help you out. Right here, you've got this funny shaped thing is his shield held up. Over here is his club raised above him. He's getting ready to do battle with our second constellation. It's supposed to be an animal. I'll give you that hint. Anybody want to guess what kind of animal this thing's supposed to be? I've heard some people say alligator. He got a long mouth and a little tiny skinny body. Could be a giraffe with a long neck and long legs. A deer, okay, maybe a similar body plan, or these could be antlers up here. This is supposed to be a bull. This is the bull Taurus. Now, Taurus doesn't have antlers. He's got horns, a little bit different according to my biology friends. But these horns are gigantic and long compared to his body, but it's still a pretty big bull. So when we see Orion and Taurus squaring up, I think Orion needs some backup. So we like to imagine his two hunting dogs are coming to help him out. And to find them, we have to move time forward once again. So we're going to continue to watch our stars rise in the east. Over here, I see one hunting dog and two hunting dogs. Now, the first hunting dog is this thing right here. We call that Canis Minor. Canis Minor means the little dog, but this is only 2 stars. So I like to call it the little hot dog, basically the right shape. Over here, we have our big dog, or the great dog, that's Canis Major. Now, Canis Major has a very bright star in it. It's a star called Sirius, the dog star. Now, Sirius is very bright. It is the brightest star in our sky in the winter season. There's another bright star called Aldebaran, which is hanging out in Taurus. And there are 2 bright stars in Orion. Now, it's easy to confuse these stars. They're all around the same brightness. And I want to see if I can help you out. And to find all of those stars, you need 3 very important guide stars. These 3 that are Orion's belt. If you can find the belt, and you're looking from here on Earth, I'm assuming you're on Earth, you should be able to see a red star on one side and a blue star on the other. The red star is called Betelgeuse. The blue star is called Rigel. Now, when you find these 2, red star Betelgeuse, blue star Rigel, you've found 2 of these bright winter stars. If you've got Betelgeuse on your left and Rigel on your right, you might have to turn your head a little bit depending where you are on Earth. Above you should be the star Aldebaran. That's the eye of the bull, the eye of Taurus. And below should be Sirius, the dog star. Now, these 4 stars are all going to be beautiful, bright objects, fun to point a telescope at, really good for taking photos of. But these bright stars can all be found from these 3 belt stars. So 1 to the left, 1 to the right, 1 going forward, and 1 drawing back. The 3 stars should point you to pretty much all 4. Now, there are some other really cool things to see in this part of the sky. I want to give you a chance to see as much as possible. So I'm going to cheat for just 1 second. There we go. Give you a nice pretty view again. Now, when we're looking at Orion, you can see him here. You can see Taurus the Bull there. You can see another cluster of bright stars way up there. That is a cluster we call the Pleiades. And the Pleiades is absolutely beautiful. Oop, wrong mark. There we go. The Pleiades right here, if you were to point a big space telescope or a powerful Earth-based observatory, you can see this is a bunch of young stars, still in the cloud of gas they were born in, hanging out all next to each other. When I say young, doesn't mean the same as maybe young for you and me. We're bipeds. We live maybe 100 years. For a star, they live 1,000,000 to 10 million years, which is still a very short amount of time, probably closer to 10 to 100. But that's a short amount of time, because if you think about a 10-million-year-old star, that was born between when the dinosaurs died and today. That's really short. Our sun will probably live for about 5 billion years. Excuse me, 10 billion years total, 5 billion years from today. Okay, so those are very young baby stars, but those are not the babiest stars we can see, because right next to those belt stars for Orion, we have the Orion Nebula. This is a beautiful, what we call stellar nursery, where baby stars are just beginning to form. We can even watch some of them forming planets around them, which is a really cool thing. Okay, so that's some cool stuff to check out in the night sky.
All right, well, we're going to take a moment, and while we are doing some things in the back, we have some questions that have kind of popped up. So
Awesome.
I wanted to leave some time for questions that have come in. And so the first question that we have is, how does a star get their name?
That is a great question. Kind of a challenging one, too. When we're talking about how a star gets its name, has anyone here ever played the game telephone? Where I whisper something to someone, they whisper it to the next person, they whisper it to the next person, all the way around the circle until it comes back to me. It turns out when you whisper something this way, you don't always get the same message coming back from the other side of the circle. That's basically what happened with star names. When the ancient Greek and Roman astronomers were writing stuff down, they were focused on the groups of stars. They didn't spend much time naming individual points. They would name Taurus, not Aldebaran. The stars were named by our Arabic and Near Eastern astronomers who were focused on mapping the individual positions of those stars, and they wanted to give them individual names. So from them, we get the name. But the problem is they told the name to someone who didn't speak Arabic, and then they wrote it down, and then someone who didn't speak either of those languages wrote it down again. And over hundreds of years, I should say, the names have changed a lot. So they're probably based on Arabic names. But those Arabic names have either mutated to the point where we don't understand what word they were, or they only barely sound like the word that they used to be. So history has changed astronomy.
All right. So another question that we had that came in was, how do only two stars make up a constellation?
So a constellation is whatever we decide we want it to be. When you look at constellations, there are two I can think of, which are weirdly both dogs that are only two stars. One of them is the hunting dogs, the other one is Canis Minor. When you're talking about 3-star constellations, there's a whole bunch. Generally, what's happened is that when people are looking for the objects in the sky, we're trying to divide the sky into regions now, much less connecting the dots to make pretty pictures. And both of those have persisted as things that are, pardon me, those have both persisted as things that are important enough for astronomers who want to note that region, figure it out, but not necessarily something that looks like a cool animal in the sky.
All right, and I think we're going to take maybe one more question,
Okay.
And that is going to be, we saw that kind of stellar nursery. How do stars separate when they're from that stellar nursery?
So one really cool thing you can imagine is 2 stars are orbiting each other, but the stars aren't necessarily equal size. One star might be really big, the other star might be really small. And if there's a big star and a little star, the little star is going to be moving very fast around the big star. It's kind of like me holding like a 30-pound kid and us spinning around if some star comes close enough to that pair to disrupt that, the little star can get let go and like it's fired from a slingshot, just get fired out of the stellar nursery it was born in. We think that's probably what happened to our sun. We got launched out of our stellar nursery 5 billion years ago, and we've been traveling alone through the universe ever since.
All right. Well, speaking of our star and our own solar system, I think right now would be a great time to kind of explore our solar system and see what there is.
Super cool. So hopefully everybody recognizes this planet. This is, of course, Mars. No, planet Earth. We're looking down on planet Earth, and that gives us a privileged view. This is an awesome opportunity for us to see really cool things on the surface. But interestingly enough, my mouse doesn't seem to be doing anything. Let me check that out. Okay, there we go. Now we can do something. So looking down on planet Earth, we can see the dark side of our planet where human civilizations are providing the light. You can sometimes see awesome features like the Nile River right here, emphasized in the glowing lights of human cities. Over here, you can see the entire Italian peninsula outlined in lights, especially the mountain range, the Alps to the north, where human cities go right up against it. Looking at this, we have a chance to see our planet in some really special ways. Our species is the only species we've found so far that builds things like cities and super cool things like our very own International Space Station. So when we're looking at this awesome planet, planet Earth, we have a chance to see really cool things in our solar system and on planet Earth. But I want to see if there's an opportunity for us to see something you are interested in. Something maybe would be a cool thing to check out, maybe another place in our solar system.
All right. And to do that, we are actually going to take a poll to figure out where we want to go next. So really quickly on our screen, I am going to launch that poll and let us know, where do you want to go in our solar system? And go ahead and take about a minute to vote.
See lots of cool ideas.
Some Jupiter, some Uranus, Neptune.
A lot of Pluto fans.
A lot of Pluto fans.
Mercury gets no love.
Oh, I think it's cool. All right, take about maybe 10 more seconds. So 5, 4, 3, 2, and 1. All right. So looks like we are going to Uranus.
Okay, so
Close though.
yeah. When we head out to Uranus, we are taking a big trip. And this is the kind of trip that we do not send human beings on. When we send our spacecraft out into space in conditions like this, they are going on a trip they don't come back from. We have sent some stuff out to go visit some of the objects nearest to us, mostly what we call near-Earth objects, things that exist in our own part of the solar system. But when we're traveling to the farthest part of the solar system, we are entering deep into the realm of what we call the robotic probes. Now, we have sent some robotic missions out to go visit Jupiter, which is technically in the outer solar system, as it were. We have sent some robots out to go visit Saturn. Once upon a time, we sent 2 robots that were supposed to visit the outer part of the solar system. One of them was called Voyager 1. The other one was called Voyager 2. They were following behind our Pioneer mission, but they were the ones that were going to do the real science, the ones that were going to teach us a ton about these distant places. The challenge was Voyager 1 got diverted. It flew in close to Saturn's moon Titan, and only Voyager 2 completed the grand tour and visited all of the outer planets. Everything we know about Uranus comes from Voyager 2, and from a few telescopic observations here on Earth. So Uranus is kind of a mysterious planet. When you look at it, though, one amazing feature is that beautiful robin's egg blue color. That's real color our eyes would see, not scientific coloration we sometimes see in other images. This robin's egg blue isn't complete, though. You'll notice there are some dark clouds. There's even some yellowy features that pop out, which could be buildup of different kinds of gases, often sulfurs or methanes on the surface. Overall, the methane and ammonia that make up a lot of their clouds give it that beautiful blue color. There is something very unusual, very strange, the tilt of Uranus. Uranus, you'll notice, is actually tilted towards the sun. Now, when I say that, I mean that North Pole, where that yellowy region was, is pointed in the direction of our star. That would be like if Earth's North Pole was tilted towards the sun. Would look pretty funny. So most of the planets of our solar system kind of spin around like this. Uranus spins like this, with its pole facing forward, and that's wacky. We have seen a couple other planets with weird tilts, much like Pluto and Venus, but when we're talking about Uranus, it is beyond the pale. It is a huge tilt and something that we are still struggling to understand. There are some guesses about what might cause it, but nothing that conclusively answers the question. Now, most of Uranus's moons are small moons that are probably orbiting in the plane of its disk, right around those rings. So they're little tiny moons that aren't that interesting. But there is one that is absolutely fascinating. It's a moon called Miranda. Now, for a long time, we called Miranda the Frankenstein moon because it doesn't just look like one moon. It looks like somebody took a whole bunch of moons and sort of duct taped them together. Now, that's weird. By itself, that's weird. But, sorry, we almost crashed into Miranda. When we look at it up close, that grayish surface is completely non-uniform. Some places are smooth, other places are bumpy. Some places are jagged, like they're volcanically acted. Other places are covered with ancient craters. But there is one spot called the crustal dichotomy on Miranda that has something absolutely wacky. It has a 12-mile high cliff. Now, we've never seen something like that here on planet Earth, for sure. We just can't have mountains that tall. We think this might have been a place where the crust split or cracked. There's a lot of potential solutions. None of them seem to be perfect as of yet. So Uranus is good at confusing scientists, and until we get another mission there, a lot of those are just going to remain mysteries.
All right, so as we're zooming on out from Uranus, thank you so much for helping us explore that very mysterious planet. We are going to go ahead and take one more poll and see where's the second place we want to visit. And I think we have time today to visit definitely two. We'll see how our timing goes if there's a third. So go ahead and vote. Where is the second place you would like to go in our solar system?
Team Pluto's pulling strong.
All right. Well, we got some.
Jupiter surges up late in the results.
Yeah, we got some inner planets too: Venus and Mars.
Don't know love for
All right, go ahead and take about 10 more seconds. All right, in 5, 4, 3, 2, and 1. All righty, let's go ahead and see. Looks like we're going even further out in our solar system. We are definitely going to Pluto.
Okay, so we are heading very far from our sun. You could probably send a mission to Uranus or Neptune. Might take between 7 and 8 years to get there, depending on where they are in their orbits and where Earth is. But to get to Pluto, we sent a mission there as fast as we possibly could. And that mission still took 10 years to get there. Pluto is very far from the sun. You can see that pale blue orbit on the outer extremes of the inner part of our solar system where our planets are. So heading to Pluto, we are traveling at planetarium speed, so we don't have to wait a decade to get there. But when we get to Pluto, you might notice it's not alone. It actually has several other moons traveling around with it. Pluto is at the center of this system. You can see it right down there. So Pluto has 5 moons, but one of them is so big, I would hesitate to call it a moon. And that is the moon Charon. Let's take a second to zoom in on Charon. Charon looks a lot like Pluto. They seem to be made of similar stuff. Pluto has dark features on its surface, and Charon does too. And the weirdest part is, those dark features seem to be facing each other. So some people are guessing that maybe Pluto and Charon are shooting material off their surface that's landing on the other object. Now, both Pluto and Charon will seem to have these black regions where someone took like a bite out of them. That's just the part that was facing away from the New Horizons mission as it flew past. So we don't have good photos of that part. So looking around here, you can see a dark region on the surface that I think is one of Charon's coolest features. That's what we call the Mordor Plains. Now, Mordor is from the Lord of the Rings books. A lot of the features on Charon are named after made-up fantastic places like Star Wars, Star Trek, and Lord of the Rings. So we're going to tilt back towards Pluto, and when we do, you'll notice some similarities. But the biggest change, I would say, is the color. Now, Charon is sort of gray, and we think Charon is fairly rocky. Pluto is white. Now, if you saw white on the surface of planet Earth, what would you say it was? Cake flour? Paint? Snow and ice are probably the best. Clouds would look white from above for sure, but if they look white on the ground, it's probably snow or ice. Now, looking at Pluto up close, we can see a lot of white. It's ice. Not just any kind of ice, it's water ice. The same kind we have, maybe the kind you put in your drink or you cool down your food with. So looking around here, we can see that the ice isn't complete. There are old spots where there's ice with craters on it. Then there's these weird smooth spots. One of these is very pale white. This is what we call the Sputnik planation. Now this is completely smooth. Normally in astronomy, when something is on the surface of a planet, if it's got lots of craters, we think it's pretty old. It's been hit by lots of objects over time. This place is completely weirdly smooth, and we think it is brand new. This is probably a nitrogen glacier floating on the surface, and every time an object falls and hits it, it would leave behind a crater that would then immediately get covered over by bubbling material. And perhaps the strangest part, right next to it, we can see what are called the dragon's teeth. These are super sharp, jagged ice mountains, and they're what we think are a sublimation feature. Now, evaporation is when you go from a liquid to a gas. Melting is when you go from a solid to a liquid. Sublimation is when you go from a solid straight to a gas. Now, sublimation happens a few special spots here on Earth, generally on the top of very tall mountains, where we see ice turning straight into vapor. But we think that is exactly what formed those mountains. They're being carved by sunlight, turning Pluto's surface into atmosphere. So Pluto is an amazing, varied, and wonderful world. There's a lot of exciting stuff there. When I was in school, we learned that Pluto was probably just going to be a ball of ice on the outer edge of the solar system. Not that exciting. We decided it wasn't a planet. Then the New Horizons mission got there, took photos, and taught us that even if it's not a planet, it is still one of the most amazing, active, and exciting places in our solar system.
All right, and with that, I want to make sure that we have some time for questions, and lots of questions have come in to our time together. So since we were on Pluto, I know a lot of you are wondering, why exactly is it called a dwarf planet and not a planet anymore?
So when we're looking at Pluto, it seems like a planet, right? It's round, it's got a nitrogen ocean on one side, it's got a big moon, even though it's kind of not a moon because they orbit each other. But why don't we think it's a planet? Well, it's because once we found Pluto, we also found Eris. And Eris hangs out in kind of the same part of the solar system as Pluto. And then we found Haumea and Makemake, and it turns out there are a whole bunch of these things hanging out in this part of the solar system. And that means, well, if we're not going to count all of them as planets, maybe we should count none of them as planets. And if that's the case, well, then we need to call them something. We can't just call them not planets. They are kind of like planets, but they're a little too small. They don't boss the other stuff around in their part of the solar system. So let's just call them dwarf planets. So dwarf planets is the name that is stuck, and I think that's a pretty cool name.
All right. And then we had another question that came in about talking about do all planets have moons?
Hmm. So when you look at Pluto having a moon, when you look at Jupiter having a ton of moons, even Saturn with the most moons in the solar system, it seems like all planets have moons, except Mercury and Venus. Mercury has no moons, Venus has no moons. Earth only has one moon, and Mars only has two. So if you look at the 4 planets of the inner solar system, we only have 3 moons. Not every planet has to have a moon, but a lot of planets seem to have a moon.
Okay, thank you so much. So kind of going back to when we were talking about the night sky, we had a question about how are these constellations named, and who gets to decide the different shapes?
But once upon a time, anyone who walked outside could look up, look at some stars, make up a story, and say, boom, that's a constellation. There were a lot of different constellations, and some of them overlap. So, a while ago, when scientific societies were first starting off, one of the very first ones to form was called the International Astronomer Union, the IAU. And the International Astronomer Union decided that they were going to be the body that got together and talked to figure out exactly what they were going to call constellations and planets. However, when you've got 2 constellations that overlap or 2 names for the same constellation, what are you going to do? They decided they had a whole panel come together and pick just 88 constellations. They decided that those 88 constellations would cover the entire sky and there'd be no space for new constellations. They had discrete boundaries and they were going to define everything into one of these boxes. That was a great system. Unfortunately, it crosses out thousands and thousands of years of storytelling from other groups in other places. It crossed out a lot of amazing constellations that I think were really cool, and a bunch of constellations that were too big got chopped up into smaller pieces. All of a sudden, we have names like the hot air balloon and the microscope and the little triangle that become real constellations, but amazing stuff like the fox or the llama disappear from our night sky, even though those were constellations in their own right. So today, if you want to, you can go outside, you can find a group of stars and call it an asterism, which is a picture in the stars, but there are 88 constellations.
All right, thank you so much. So we had another question that came in about are there aurora borealises on other planets, just like we have here? And could you talk a little bit more about like what that is here on
Sure.
planet Earth?
So when we talk about an aurora, it's the light coming to us from someplace. Normally it means the dawn, but when we talk about an aurora borealis, we're talking about something that ancient astronomers and people on Earth used to see called the dawn of the north, which was weird light that showed up. It wasn't orange yellow like our normal dawn, the sun rising. It was green and red. So people came up with all sorts of interesting stories to explain exactly what this was. But fundamentally, it's particles from our sun shining off to hit us here on planet Earth. And when it hits us, it interacts with our atmosphere. Now, if we have a chance, I think I can show it to you, but we got to go all the way in to our very own Earth. Here we go.
All right, and as we do that, that's kind of interesting that we can explore that here in our own planetarium software. Can you remind us how we're actually viewing this today?
So we're checking it out in something called UniView, which is the software we use at our planetarium. But if you folks want to check it out, there's things like Worldwide Telescope and the Open Space Project that are free. And you can use in your classroom, you can use them anywhere you want. Both of them are done in conjunction with the AAS, the American Astronomical Society, and NASA is funding open space. So we're zooming into planet Earth. And hopefully you can see that. You can. Great. And when we're here, around the north and south pole are where we would expect to have our aurora. Now those are coming to us from the sun. The sun is blasting out particles in every single direction. They slam into us, but you need 2 things to get an aurora. You need a magnetic field and you need an atmosphere. Thankfully, Earth has both. Now, when we're tilted towards the sun, you're going to get better aurora in the summer. Unfortunately, in the Arctic, where the aurora happens, you don't get nighttime. So we can't see those quite as well. So in winter is where we really expect to see the best aurora. Earth has been seen to have aurora. There's been tiny flickers of light in the Martian atmosphere, which might be something like an aurora. Jupiter and Saturn have some of the best auroras in the solar system, though. If you really want to see aurora, that's the place to go.
All right, so we just need to travel out to Jupiter and come on back.
Easy.
Easy. Um, so another question that has kind of been popping up is talking about our own sun. And you had mentioned that we have about another 5 billion years left with our sun. What's going to happen next?
Okay, so our sun does a couple things. Number one, it takes hydrogen and it turns it into energy. That's what our sun does. We call it fusion, and we can see how much hydrogen makes up our sun that it could use, and we see how much energy the sun is putting off, and that tells us eventually that hydrogen will get used up. When that happens, our sun will change how it shines, and it'll turn into a red giant. Our sun's about 5 billion years old. We think we've got about 10 billion years before it stops shining. But when it's 6 billion years old, it'll probably start to change into a red giant. That's only a billion years from now, but at the same time, it's a billion years from now. But when that happens, the sun will start to expand outward. It'll eventually cover Mercury's orbit and then Venus's orbit, might get to Earth, and some models even have it pushing past Earth closer to Mars. If that's the case, Mercury, Venus, and Earth will be inside the outside layers of the sun, which is not a super fun place to be. What will happen after that is eventually close to that 5 billion year in the future mark. The outside layers of the sun will puff off, traveling out into space, and when they do, we're going to turn into an object very similar to the one called M57, or Messier Object 57, which is kind of a preview of what our sun will eventually look like. So if you want to see that, Google M57 or Messier 57.
All right, so we have a preview of what will to come.
Yeah.
Cool. So another question that's been kind of coming up is how are stars named, and can we actually name one after ourselves?
So the names we have for the brightest stars date back to those ancient astronomers like we talked about before. But if you go online and you fill out one of those things, say, I want a star named after me, it's not going to be one of the very, very bright stars because those have names already. There's going to be people who tell you that there's going to be a tiny star in this constellation named after you. And they will write your name down. They will keep your name safe in that database that they keep that says this star is named Jeff, if Jeff's your name or Jeff's the name you want to give the star. The problem is that astronomers, we don't usually look at those teeny tiny stars. And even if we are looking at that teeny tiny star for some reason, we don't go to that company and ask them, what do you call it? We just come up with a name for it, a number usually, because it's easy to keep track of numbers in a computer. So if you want to name a star after someone and you think that's a really cool thing to do, that's a fun gift. It's something that is interesting and kind of different. But if you want a name to be something that astronomers use, we don't always ask companies to find out what we should be calling stars. We come up with our
And sometimes those aren't as creative, like you said, numbers
HD
or
1005631.
Yeah, not that creative. So astronomers not creative in naming things.
They come up with license plates.
Okay, sounds good. So another kind of question that has kind of been popping up is talking about other planets around other stars, and are there actually planets the same size as stars?
So we've seen really big stars, we've seen really small stars. We've seen really big planets, we have seen really small planets. The toughest part is, where do you get the smallest star versus the biggest planet? Do they touch? Do they overlap? I would love to give you a solid answer. I don't think astronomy has one. The rule we have for if something is a star is whether or not it's making energy. That same fusion thing we talked about before, turning hydrogen into energy. If something is doing that, we call it a star. If it's not doing that, we would call it a planet. So sometimes we see little things that aren't doing fusion, floating by themselves through the universe, which we call a rogue planet. They're all by themselves. Sometimes we see something that is doing fusion like that, traveling by itself. We call it a star, like our sun. If we see two objects going around each other, they could be binary stars, in which case they're giving off light. Both of them are doing fusion. But if one of them is doing fusion and the other one isn't, then we would say it's a star and a planet. We've never seen two rogue planets orbiting each other, which could be a failed binary, two stars orbiting each other. They must exist, but they're so faint and hard to spot, we just haven't seen them yet. So there could be very big planets, there could be very small planets. If a planet is big enough, it'll start doing fusion because it's probably made of hydrogen, and we'll call it a star.
All right. There's a lot there, but
So very complicated.
well, we definitely want to say thank you, Josh, for your
My pleasure.
exploration. I know a lot of new questions popped up in our chat box, and I'm sorry that we're not able to go through all of them. Again, we're a very large group, but we will be looking at these questions and write up some answers or send you more information on where to explore these ideas a little bit further in an email in the next couple of days. So we want to thank you all very much for exploring with us today and hope you have a wonderful rest of your day. Thanks, everybody.
Clear skies.
Bye.